I'm Beltran Calise.
My name is Jerome Castillo. I'm Dylan Forrest.
I'm Matt.
And we're the Django Translators team. So before we start, let me give you a little background about the company. Language Intelligence is a language provider company based in Rochester, New York. They were founded in 1988, and they offer translating services, interpreting services, as well as language and culture training services. This is the second time they work with a senior project, so we picked it up from the previous team from last year. So here's the problem. Language Intelligence needs an efficient way to translate files. The company wants a way to collaborate with the customer in one place, where the customer can view the translations in real time and see the actual progress that the translators have made without having to resort to any methods of communication outside that. They have a current solution, but it's outdated since it was made in 2006. And they want a more user-friendly and better user experience for their solution. So this is the solution to the problem. It's a platform that allows translators to translate content in a convenient and efficient way. Unlike other translation review platforms, IntelliReview displays translated content within the context. It also has customizable style sheets and formatting that it is contained within the file. It allows for comment suggestions from both the customer and the translators, involving high customer collaboration. By translating in context, both the customers and the translators can make any comments and suggestions. And as you can see here, we have an example. That's a default format that we have. It's side-by-side with no styles being applied. You can see there's some actual HTML tags in there, but that's just inline style. The thing is, Language Intelligence allows the actual customers to see the file in the original format and the translated format as it will look. And here's a quick use case diagram of the process of translating a file. The admin will originally upload the file that's provided by the customer. Then it will create a project and assign a translator and a customer to it, which will then give them access to review the file. Then the translator will add translations and make suggestions which will then be approved by either the translator, other translators, or the customer. The customer also is allowed to make comments in the file, which will then be approved and added to the file by the translator.
So here's a bit of a domain model of how this works. Like we said, there's a project manager who manages the project. They add users and files. The users are translators and reviewers. Translators have a full set of permissions in this. They can create changes, suggest changes, whereas reviewers have a subset of these permissions. They can only suggest changes. These are all done on a mock-up of what will be the final format. The parser creates a mock-up, and as these changes and suggestions and stylings are defined by the users, once that's completed, it will create a finalized file format by reconstructing all of the bits and pieces.
So in the first few weeks of this project, we met with the previous team and we went over what they accomplished in their whole semester. We saw that they had a basic prototype site, they had logging in, they had a homepage, and you could even see some of the parse files going forward. So we knew we had a good baseline, what we could expand on going forward. They also had fully fleshed out all the custom user requirements that the sponsor wanted, custom permissions and groupings for translators, admins, stuff like that. But there was some technical debt. We had very large functions, very large files, and stuff that the team did towards the end of their project was kind of like ad hoc, so we knew we had to expand on that and make sure it didn't affect us downstream at all. And there's also some security issues we found. You could reach certain web pages without logging in, and sometimes they wouldn't sanitize some user input. So we knew that we had to worry about stuff like that. But the most important thing from our meetings with them, we wanted to find out like what challenges did they have throughout this project. We didn't really want to repeat those same challenges throughout our year. And having to tell the sponsor for another year, like, hey, these are, again, the same challenges we faced. The biggest challenge we saw was the translation file parser. It's this backbone of the whole project. It's you take the XML file from the project database, and you parse through it and spew out some stuff in the front end as a result. The only problem is this is a very, very big subsection of the project. And when the previous team was going through and dividing up all the tasks, they assigned one person all the parser tasks. And that became a huge blocker because he couldn't finish all of it. The team was then behind schedule with a lot of blockers, and it was just a huge problem. So we knew going forward that we had to account for that, being the parser being very big. Another huge issue that they had was a very complex domain knowledge. The file formats that we're parsing have a lot of rules and like a lot of different nuances to them, so we had to make sure we had a lot of time in the very first few weeks to learn this new file format and be able to parse it effectively. Their last challenge was something they actually accomplished, though. They had some trouble getting the user requirements working, but they fleshed all that out, so we didn't have to worry about that going forward. So when we were making design decisions, we really only had to focus on the parser and the complex domain knowledge when we're choosing methodologies and what development cycles we want to try. This takes to the beginning of our part of the project, the requirements phase. So we went over what the previous team accomplished for all the requirements and trying to see in the code base if they actually had completed it. They finished most of it, except for a few little bugs we had to tweak, so no problems there when we were going through requirement solicitation. From there, we went to the requirements solicitation phase, where we expanded on ambiguous requirements that had to be completed, like must allow for management of supporting ancillary files and stuff like that. So once we expanded all about that, we were able to categorize all the requirements that we had to choose from to do in our project.
So like we said, there was a lot of requirements in the initial document, and we had to take some time to analyze those and really see what was what we could accomplish within our time frame. So these requirements ranged from algorithm improvements, like to the parser, advanced analysis of the content, such as spell checking, terminology identification, and the support of ancillary files. And so what we did is we took a look at this. We analyzed the code base to see what work had been done already towards these requirements and to see how much effort that might have taken. We talked to this previous team and to the sponsor to really figure out what the priorities were and what had been the main challenges already. And so then we did wideband Delphi estimation to see how long we thought that the existing requirements would take us, and kind of distilled a scope commitment that we then presented to the sponsor. With this scope commitment, we committed to 3 high priority requirements: a fully functional parser. Like we said, this is the main backbone of the program. It will take all the extraneous parts of the SDLXLIF XML, present them, and then reconstruct them with the edits. We also committed to a file display fallback mechanism for displaying files when the style when there's not a currently applicable style, and customized display formats of the files. So you can say bold tags should actually be italicized, or vice versa. We committed to 2 medium requirements and 6 low priority requirements as well. Yeah.
So for our process methodology, we decided to go with Spiral and Extreme Programming. We chose Spiral because we knew that the previous team had a lot of difficulty with their parsing strategy, and they had lots of blockers, and we wanted to mitigate that as much as we possibly could. We wanted to identify risks as early as possible so that we didn't fall into the same pit traps as they did, and we wanted to make sure that we had a very solid understanding of what we might have to do in order to mitigate those risks early on in the project cycle. We decided to continue forward with Extreme Programming because it's iterative, it allowed for pair programming, and it allowed us to work in 2 to 3 week iterations, and there was a very heavy emphasis on test-driven development from our side, just to make sure that we didn't have as large blockers moving forward. Any blockers that could have occurred would have happened when we started thinking about the risks and the tests that were going to be implemented on the system itself. We initially, for metrics, decided to go with function points, but as time progressed, we realized that the parser and the front-end parts of the system were so large and so monolithic that function points would have been very difficult to accurately show what we were going through. So instead, we opted to identify what defects and how large the files got. We decided to look at the number of defects and the 1,000 lines of codes for our product metrics. For our process metrics, we decided we were going to identify how long one person was working on a particular part of the project, to identify whether there was a blocker or whether there was more difficulties that were not picked up upon during the risk and test planning phases. For our design, we decided to choose largely what the previous team had done. We decided to follow what they had already started. We were informed that the previous team took IntelliReview 1.0, which was created in .NET, and decided to update it in Django and React. So we didn't want to reinvent the wheel for what they had done, because essentially they were recreating IntelliReview from the ground up in Django and React. We followed an MVC model using Django, and there was a large emphasis on the parser, which is the major backbone of the project. We decided that since the previous team had started using React to render what the parser would ultimately send up, they had created a pseudo XML tree structure to send up to the front end that would eventually get created into JSON. We decided to cut that and just send up from XML, parse it into JSON, so that it would be faster, so that it would make more sense to the front end when they received all the data that they were going to receive. The project and file management and user management systems, we took a look at those, and they stayed largely the same, but we wanted to make sure that they were fully functioning moving forward.
So this is our technology stack. As we all mentioned, it was defined by the previous team and approved by the sponsor. We felt comfortable working with it since most of us had previous experience working with it. We also thought that it was fitting for this kind of web application, since Django and Python allowed us for rapid development and efficient code, mostly working on the parser. And React was great working with conditional rendering, since we have a lot of dynamic rendering based off the custom styles or custom format being applied, so that was great for it. And also, we continue going with SQLite, since a relational database is very fitting for this kind of project, since there's a lot of relationships between files and users and projects.
So in the implementation phase, we had 6 2 to 3 week cycles, which can be grouped to 2 major phases. Our first phase being kind of the learning phase. We tried to go through the existing code base, figure out how it works, and fix any major bugs that are in there. And we also tried to get rid of some of the technical debt that was already in there, fixing some of the larger functions and sprucing up so it didn't become a blocker down the road. This was pretty short. It was only about 4 weeks or so, but it was very important before we got on to the next phase, our development phase. We decided to do test-driven development here because it was kind of ambiguous what the sponsor wanted sometimes. So we made some final products from our parser, and then we gave it to them for consideration. They gave us feedback on data that we were missing, data that should be there that isn't. And after doing stuff with that, we went on to test-driven development. Basically, we did work on the parser and try and get as close as we can to that final mock-up that the sponsor wanted. That was very useful. And then for the front-end side, we just tried to incorporate that into our front-end parsing methodology as well as adding some new features like side-by-side viewing for translations on one side and untranslated stuff on the other. And we did pair program for all of that because they were just such big components of everything, and it was very nice to have someone just to help you work on it as you went along.
So here you'll have a look at our existing system architecture. As you can see, there's 4 main modules, not including the presentation layer. The parser module and the projects module hold a lot of the code for this project. This actually, as we said, was a challenge. The parser module is somewhat monolithic, and it's hard to decompose this. The parser has one goal. It's very cohesive. It's meant to parse the SDLXLIF XML. But since it's so large, we had difficulty measuring our progress except by functioning code. Additionally, the user and project modules are somewhat coupled. Users have completely customizable permission roles for the projects. An admin can say that they're allowed to can have any permutation for a given permission role. which made logic between those somewhat dependent between each other.
So testing was a huge part of our project. We had a lot of test-driven development for most of it, probably say 4 cycles of it. We did tons of acceptance and integration testing, and I'm sure a lot of teams did, but we did a huge focus on that, especially on the parser side, because we made the final product, and then we did a lot of acceptance testing and integration testing to make sure it worked properly at the front end, and it was what the sponsor wanted. We also used Postman for testing our API endpoints and trying to get all the bugs out of there. And we presented prototypes for the sponsors for acceptance testing. We did a lot of the JSON. Some challenges we had. So we tried to learn off what the previous team had challenges with, and we tried to fix all that, but we couldn't really avoid the domain knowledge challenge. We had a lot of front-end learning on that, and it was kind of a struggle to get our head wrapped around the STL XLIF format. Because XML has guidelines, and XML has a lot of good guidelines you can find online, but STL XLIF, as our sponsor put it, it's like the Wild West. There's not a lot of guidelines you can go off of. So we had to kind of just go through all our STL XLIF test files and figure out, okay, what's common between them, what can we always parse out, and make sure it's always there.
The result of this is we were able to fix most of the bugs that we found initially in the system. We started off with 16 bugs, and we fixed approximately 12 of those major bugs. We mitigated a lot of the vulnerabilities. We actually made it so that you could no longer just enter a project out of the blue. You had to logged in. You had to be logged in with the system before being able to view any of the projects that were currently available to you. We improved on the existing design, especially when it comes to the parsing strategy. We wanted to make sure that what we were sending up to the front end was easily digestible, quick. There was a focus on performance. We wanted to make sure that the parser was working at least 80%, if not better, for most of what for most of the life cycle. And we made sure that there were some good optimizations in the front end so that it worked very closely with our back end to make those improvements. Our future plans are we want to make sure that the parser is 100% complete by the end of the first month of next semester, as well as we need to make sure that the parser can reconstruct the SDL XLIF files that they deconstructed with the final changes that the translators had, with the suggestions and comments and such. We want to make sure that not only with the side-by-side formatting, but other custom formats are available to the users, to the translators, to the project managers. Those formats can be applied at a project level or a file level, and there are a lot of nuances with those formats. We want to be able to keep track of any time that is spent on the site. Translators, reviewers, managers, we want all of that time to be logged so that audit people can understand and view how much the site is being used, in what sections, and how it's being used. And we need to make sure that the email server is hooked up to allow for user experience for the project manager, so that they don't have to send emails to every single user on the project, or when it's done that they get a email that says so. Any questions?
With the code that we're writing, the problem is there's not a really clear definition of what's valid. This translation, the translated files are largely, you can have a lot of input. So the users can say this translation wasn't exactly accurate because of the nature of it. You can have trademarked names, you can have company names, different modules. So what we did is we did include some unit testing, but the real focus was largely on making sure that there was acceptance from the sponsor. Currently, I don't actually know what our unit test coverage is, but we can look into that and report back.
Because you had said that you had fixed like 12 bugs and you'd mitigated the
progress-wise, we added 11,000 new lines of code, which isn't very helpful for telling you like what new features we had completed. Requirements-wise, I think out of the 12 we committed to, we completed about 2 of them, with the parser being like 2/3 done, I'd say. Those are basically like 1 high priority, 1 medium, and then 1 small I've been done so far. Once the parser's done, though, that frees up 2 developers to work on other high priority development stuff, because the parser's the backbone. We need to finish that before we can move on.
On top of that, the parser really entails a lot of the complex domain knowledge, and that's where a lot of the effort lies. That's really the stuff that we had to learn and figure out and apply a lot of thought and development to. So we use the XML etree library and the Python JSON libraries. They've been really helpful. In fact, I can't imagine how it could be made easier through those with such a complex domain.
The SDLXLIF file format, the test files that we were using were built from XML files. So there's an XML attachment to the SDLXLIF file format. And the etree allowed us to get it in a format that Python was easily able to pull out any attributes that it had and allow us to parse through and render all the information that was inside of those XML tags, essentially.
Any other questions for the team? All right, let's thank the team.
So hey everyone, we are Team Smarticus, and we're working on the software maintenance asset repository and tracking system, also known as SMARTS for Lockheed Martin. I'm Christian Borges, the project manager and a software developer.
I'm Joey Bovio. I'm the software developer.
I'm Alex Wilczek. I was another software developer and the test manager.
And I'm Zach Moran. I've been our customer contact, and I've also been developing software as well. Our faculty coach is Parul Patel, and our sponsors Jamie Whiteman and Eleanor Stevens have been fantastic. Just to go a little bit about what we're going to talk about today. First, I'm going to go over some context, give you a little bit of an idea about what the project is, where it comes from, and then we're going to jump into some of our process, talk about our development model and how we utilize Jira to really aid us in that task, and then jump into some design, a short demonstration of what we got so far, a little bit of reflection of how we're doing this semester, and then talk about the future and go into some questions. Just for some context, Lockheed Martin is the largest aerospace and defense company in the world. Their current mission statement is to advance the boundaries of science and protect our citizens. And to do so, they have many areas of business. Specifically, the Rotary Emission Systems, RMS, is the realm of this project. RMS currently manages thousands of software assets manually, and this is where we come in. So with our project, we needed to be able to monitor and maintain all of those assets. And right now, all of that is done in one Excel sheet. Yes, one Excel sheet. There's thousands of rows, hundreds of fields, and they're trying to keep that in a manageable system. So as you can expect, this is very difficult. So it lacks the proper optimization. It has a high entry barrier for new employees to get into it because it's just way too much to take in. It's really overwhelming. And our solution to that is Smarts. It's a web-based asset management application that will streamline the existing process and make it much more accessible for new employees to come in.
So this is a list of the high-level requirements that Jamie brought to us on week 1 of this project. Smarts needed to allow users to be able to manage, meaning create, modify, and delete assets, vendors, and portfolios. They also need to be able to initiate maintenance, which basically means put out a request to a financial personnel or to a portfolio owner to renew their software assets when they're about to expire. The system also needs to allow for the importing and exporting of data, so they can take their current data and put it in the system, and also export data should they need to use it outside of the system or in some other application. There's also the need for dashboards and reporting, which is the main deliverable for this semester, which are basically graphical and textual analytics for various asset data. The system also needs to support financial management for asset budgets so that the users know how much they're spending on assets currently and how much they plan on spending in the future. And there's also needs to be group-based access levels so we can lock down certain features to certain user levels, and also the usage of a relational database so that all this data that's currently in one giant table can be broken out in a manner that's much more easy to view and easy to manage. There are a couple of things that were out of scope for this project, one of which is being the mobile application. Originally, Jamie asked us to create a mobile application so you could also have some of this functionality on your mobile device, and we pitched to him that we would design the web application to be responsive in a way that you would be able to view it on your mobile application or mobile device without needing to build a separate application for it, and that was approved by Jamie. A couple stretch goals: in-application fixing of imported data, and also the usage of Entity Framework, which is just an alternative method for our application to interface with the database. So now we're going to get into some of the process we used for this project. The development model we used was iterative and incremental. We chose this model because it allows for frequent communication with our customer. Every iteration we are able to come to our customer and provide and show them what we have created and what we have for them, and get feedback on that so that we can quickly incorporate that into the coming iterations. Another thing with this model is it allows us to have all the high-level requirements defined from the beginning of the project, and then at the beginning of each iteration, we can take a deeper dive into that iteration's requirements and make sure that those are still up to snuff with what the sponsor wants, and also ask any questions and get anything clarified that needs to be clarified. Lastly, it allows us to continually build upon the product that we're building each iteration.
So we had a very heavy and early focus on requirements gathering, and that made us realize very quickly that we need a platform to be able to manage all this, record it, and keep it organized as we go and progress through our development. So that just made it obvious to us that Jira would be a great platform for us. This is especially because we've all used it during our co-ops. Our sponsors and mentor could easily log in, take a look at our Jira, see which tickets haven't been completed or haven't been worked on. And also it allows for easy time tracking where we could just input our time into each of the tickets and generate helpful reports of that. You'll see this picture right here is our epics for this for this semester by iteration. So that's iterations 1 through 6. So within those epics, we have the user stories. Initially with us focusing on gathering all the requirements and turning those requirements into user stories, there was a lot of overhead. It required a lot of time, but we found out that it was really worth it as we progressed into our development. There was much less overhead when we actually started our development. So as you can see here, there's one of our user stories, and it has a lot of helpful information like the story points that are tied to it, who's working on it. I'm sure you guys have seen these, but time tracking. And one thing that we did do was integrate it with our Bitbucket repo, so you can see which branches and commits are related to it, to this feature. And each user story has a fleshed out use case that we can refer to as we continue in our development. So one thing that we gained out of this was being able to create reports. One of them is the cumulative progress flow. Orange is backlog, or tickets is backlog. Green is, blue is open items. Purple is in progress, and green is done. So when we started development, all of our items, come mid-October, all of our items were still in the backlog, so that's when we actually started developing. As you can see now, we still have a good deal of items in progress, and that's because we are still waiting for our sponsor approval to consider them to be done, and that's why there's only a few items in green. One thing is that you might notice a disproportional amount of tickets for this semester and the coming semester, which you'll see are all in orange at the end. This is because we had much less tickets for this semester, but they were, we had less tickets in this semester, but they were much bigger. The features were very heavy to complete. Also, with Jira, we were able to track metrics like velocity, hours per iteration, hours per user story, and overall project progress. This translates into another helpful report, which is time tracking, which is the time tracking report. And this provided us with the fact that we actually have a negative 36% accuracy when it comes to estimating time for user stories. This is obviously a big issue that we need to address going forward. So with each iterations that we'll be going into in the coming semester, we'll be taking a look at the hours that we estimated for them and reevaluate them using our experience from this semester. Another thing that we're doing going forward is tracking defect count and test coverage, and we'll be able to do that with the bug tracking system within Jira.
And from there, we can get a little bit into the testing and validation and verification strategies. So for the site functionality testing framework, we learned very quickly that because our project is based in .NET and because it's so heavily reliant on models, that basic unit testing would not be enough, and NUnit, which is .NET's main unit testing framework, would not be able to cover all of it and would only be used in very specific implementations. Our solution to this is Selenium, which allows us to do browser testing with those specific models wherever we want and allow consistent and efficient testing and results. When it comes to the sponsor validation, the two biggest points that we wanted to hit on were the dashboards and reports. They are going to be what the user sees the most, and it is very important that what they see not only makes sense to them and is parsable by them, but contains the correct information and doesn't overload them. For the data consistency and integrity, importing data, especially through that massive Excel spreadsheet, will be important because it's important to ensure that all of the data lines up and is one-to-one with that sheet. And also, we wanted to add an audit history for the assets so that if any changes were made, we could know who made them, when they were made, and if necessary, we could allow them to be reverted. So talking a little bit about design, we can start off with the architecture. And the architecture, the biggest point to make right away is that it is not a public website. It is exclusively within Lockheed Martin's network. And as such, the way in which Lockheed Martin employees will be interacting with it is largely through the view layer. They will be making changes to the view layer through either their computer or their smartphone. And those changes will be passed into the control layer through our business logic. And from there, if any of those changes affect the database in any way, they will be passed through the model and data access layer and through Lockheed Martin server. The two outliers here are Active Directory, which will be used for user authentication, and Tableau Server, which utilizes Tableau's API for the visualizations for all of the dashboards. And then getting into our domain model, the biggest point is the employee and their access level. That handles the group access policy, and from there it allows various employees of various types to access their assets, the features that pertain to those assets, and the portfolios to which those assets belong to. The biggest point with this domain model, we feel, is that this breaks down the design of that Excel spreadsheet into a human-readable format in manageable chunks. A user will no longer be overloaded with information or with information that isn't relevant to them at all. They will only see what they absolutely need to in an efficient way. And as a result, this leads into the technology that we used. We utilized .NET MVC, as we said, Model View Controller, for our system architecture. We're utilizing Tableau for our dashboard visualizations, SQL for our database, Active Directory for our user authentication. We went over the testing framework, and also just a few basic front-end tools to ensure that the UX is smooth.
Yeah, and to jump into our demonstration, First things first, when you log into Smart, or when you launch Smart, you can end up on our login page. The login page, I don't have an account right now, so I'm going to go ahead and register one. After you register one and enter all the information, you're going to go ahead and be able to sign in. Once you sign in, you'll be brought to the home page. Right now, there's no assets in the system, so I can go ahead and create one if I wanted to. But since the form is pretty lengthy and we're limited on time, I'd rather just import one. And importing is a big feature of our site. The ability to import the assets is basically they take that Excel sheet and they can choose to either drag and drop it or select it here. And let's say an employee has this Excel sheet and they put it in and they're like, okay, cool, it's going to get in the system. And it starts time to process, read all the records, make sure it's all good, and the asset validation failed. This means that there's something wrong in the file, and this right here is going to list out every single error in the file with the error count, and you can expand each row to see which column it was, what the error was, and basically just make sure that the employee can go back and have the ability to fix that information. One error in here that's a little bit unclear that you can see right now is the unknown. The unknown basically means that that row just didn't meet the specification and we couldn't parse it, so we don't know what's wrong with it, but we can still point them to the right place so that they're not spending time being like, what's wrong with my file? So after the employee sees that, fixes all their problems, they can go ahead and import one that's been fixed, all the problems are all taken care of. The site will go ahead and load it up, and once it's successful, you'll see that all the assets in the file have come up, and you can expand these rows to see the details on those assets. Right here you can see things like whether or not it needs maintenance, which is based off its renewal date. You can see who the vendor was. You can jump over to the employees to see who owns it. Its procurement information, which is basically how Lockheed Martin knows where it came from, how much money they spent, things like that. And then you can see the different years of it. So if they've had this for multiple years, you can see when it came back from. And then the budgets is basically how they plan out their finances. They can see how much money they expect to spend and whatnot. So once the employee has checked all this, it's all good to them, they'll hit confirm. It'll finalize it and bring you back to your home page. And once you're back on the home page, you can see now that the information has actually been put into the system. And as you can see here, we have two tables, all my assets and action required. All my assets, since this user is an admin, they can see everything in the system. And you'll notice that this person right here, this asset right here has a renewal date of 11/1/2018, and that was 28 days ago, so it needs renewal. That way, it shows up in the action required table. Any of these rows can be expanded to see the information that we basically just saw in the import. This is just to make sure that we have a one-to-one and we make sure that all the information actually makes it into the system. And then beyond that, this is where the main management of assets happens. You can hit the options cog and hit edit. And this is where you can change any of the information. So this one doesn't have a description right now, so we can go ahead and add it. And then let's say that we don't lease this from Microsoft anymore, we actually own it. So we need to switch it from lease to owned. So we can do that as well. Once it's all set, we hit confirm. And then we can see that those changes have taken effect. We see the description there, and we see that it's now considered owned. So now we're going to go ahead and look at the other option, which is mark inactive, which is basically a delete for the user. When they do that, that asset will no longer show up in the application. This is where our audit history system comes in. All that information will still live in the database so that if they ever did something on accident, it's still there, but it just doesn't show up in the application and they could fix it by flipping a bit in the database. So moving over to the vendors list, it's exactly what it says. It's a vendors list. This is all the vendors in the system right now. Any of our tables in our system can be sorted. They can be searched. If you want to search for any of the content in the fields, you can just do so in the search bar. You can order it by the columns by clicking on them. And then portfolios, same thing, just different data set. So moving over to reports and dashboards. Reports and dashboards, first you're going to end up with the current late renewal of assets report. This is the most important report because it shows you which assets need to be renewed right now. And you're able to export that to CSV or Excel files if you wanted to. Changing over to a financial projections report, you can see the budgets and basically like how much money they expect to spend, where they expect to spend it, what assets it is pertaining to, and whatnot. And as I said before, same search functionality and same export functionality. Changing over again, you can see all the different reports we have right now, and we'll move over to the dashboard. And this is where Tableau comes in. Tableau is fantastic at displaying information. It allows us to take all the asset information in the system, put it in a visually appealing format, and allow the user to customize the dashboard however they want to within the realm of what we allow them to do. So if they want to sort through the columns, they can do that. If they want to expand some of these columns to, let's say, have the asset owner ID and their name, they could do that as well. But it's basically just a way to make sure that the information is there and it's what they want to see. So beyond that, that's basically our demo. We're going to go home and we can log off, and it brings us back to the home page, and that's about it. And I can't do Max.
Okay, and now on to our team reflection. So we're just going to start off with reiterating on what we've completed. In September, we gathered all of our requirements and locked in our scope with our sponsors. October, it was more focused on design, so architecture, mock-ups. November, which is this month, so we completed the importing system that Zach, all these things that Zach showed. The asset management, creating, modifying, deleting them, and reports and dashboards. Coming in December, we will be handing off our project to our sponsors, and that'll include the actual application and the documentation in order to set it up and to use it.
Yeah, so to talk about some lessons learned, let's go over some good ones first. We think that our uses of Jira was absolutely fantastic for this project. Not only did it organize our thoughts, it also allowed us to keep an idea of who's doing what, when they're doing it, how long it's taking, and basically making sure that the work is actually getting done because you can see all the different statuses on the tickets. In combination with that, we also really felt we were really good about leveraging each of our individual skill sets to make sure that the tickets we assigned to each other were appropriate for our own skills. If someone was not so great at SQL, but someone else was better at it, the person that was better at it would most likely get the SQL ticket so that we could use our time efficiently. And beyond that, we just learned a lot. We learned a lot about the new technologies, and we expect to continue to do so going into the next semester.
And jumping into the not-so-great lessons that we learned, initially when we started out, we did not spend very much time on risk tracking and mitigation. We just weren't seeing very many benefits from it. Ultimately, that led into this sort of feedback loop where every subsequent issue shown here was ultimately caused by that, especially the last two, underestimating feature development and overcommitting to the feature time. We all have busy schedules, we're all students, and ultimately overcommitting and underestimating how much time they would take resulted in many sleepless nights and multiple headaches. Going forward, though, knowing what we know now about risk tracking and mitigation, having developed a proper plan for it, and planning to utilize that, we now know a lot of things going forward into the spring semester that will allow us to avoid these headaches and generally just get everything that is remaining done.
So now just to give you guys a high-level overview of the future plans. In January, we plan on implementing user groups, Active Directory, as well as the workflows for the software assets. February is going to be all about budgeting and portfolio functionality, as well as implementing our data retention policy, which will allow inactive data to be deleted automatically from the system after 3 years. And then in March, we'll be finalizing exporting results, our testing suite, and then we'll also be doing a heavy application code review. And then April to early May, we'll have our final code freeze and our project handoff. So before we jump into any questions, we just want to take a moment to thank our sponsors and our faculty coach. Jamie and Eleanor have been our fantastic core sponsors, and they've done a really great job of helping us with this project, and we've really enjoyed getting to work with them on a weekly basis. Also Jeffrey and Frankie, who are also Lockheed Martin employees who have taken time out of their own schedules to help us along the way as issues with Tableau and .NET have come up. And then, of course, Peru, who's our faculty coach. She's done a great job of helping us to stay on course, make sure we're meeting all the deadlines, and making sure that the content we produce is as high quality as possible. So with that, are there any questions?
Yes.
On your chart that has a big backlog, you guys said that toward the end, you had a lot like more tickets or less tickets or something, but because they were very verbose and like picture work. So how does your team plan to mitigate making a story that's too large for like one development cycle?
So a lot of the ones that were large in this semester really just came down to the fact that it was like create the database, design the database, things that like took a lot of time and thought. And because they were larger in that aspect, it was more of not so much that a feature was taking too much time, but that we needed to put the time in to make sure that what we designed and what we implemented initially was beneficial to the future development. So in terms of next semester, we have a lot of features, but they're a lot smaller and they're more precise, and we have the use cases that we showed, like that example, and I'm sure all of you guys know how they are. We've really gone into detail of like what we expect them to do, how they expect to flow through, and we're as we said, we have underestimated a lot, and we expect to go back, revisit those estimations, and fix it for next semester.
And then, just to follow, you said that you're also tracking development time and velocity.
Yes.
So with those two measurements, kind of what is your team going to derive from that?
So the important thing with that one, in this particular example here, not only do you see how much time is spent on the whole thing as a whole at the bottom, and you can see our accuracy with our estimations and whatnot, but you can also see how much time is spent on individual features. So let's say one of those features we're spending 20, 30 hours on, and Jamie and Eleanor then come to us and say, that's not somewhat so important, and you're spending a lot of time on it, so maybe we should move to other things. So there's a lot more benefit in tracking time on individual things, because you can see how much time goes into the high priority tickets versus the low priority tickets. So, yeah. Anything else? Yeah.
So does .NET make it real easy to access the Excel database, the Excel files and the stuff in there? Or was there work you had?
Oh, there's a lot of work. That one right there, that's 42 hours. That's that work. So that's been my baby. And I've been basically, there are libraries that allow for easy importing of things, but it's easy importing of things that are easily defined. And while we have a spec, there's also a lot of things that go into it. So like one column may need to be a date, but it's a date not in like typical 12/1/2018. It might just be like the year, and then another column over here might be the month, and I need to combine those. So like there's a lot of extra stuff that kind of prevents me from using the standoff libraries that are available to us right away. So yes.
Other questions? Let's thank the team.
So how's it going? My name is Jason Griffith, and our project is disaster communications. It is a RIT sponsored research project, and this is my team members, John, David, and Joe. So the problem that we aim to solve here is to figure out how to stably provide communications when first responders go to areas of natural disasters, such as wildfires or stuff like that. I'm sure we've all heard in the news lately about the wildfires in California and how providers were throttling certain firefighter departments, unlimited data. And this is kind of an unacceptable behavior because these communication systems are, really relied on by these first responders that go out there. So not having something in place that's stable and providing this communication, that's a real problem. In addition to the throttling which takes place from potential providers, another problem you have is within these natural disasters, if the towers go down, you also have massive outages. So being able to try and identify these areas where these outages take place, or maybe an area where a provider is shaping or policing certain traffic differently, becomes very important to be able to try and provide stable service for first responders to use. And the end goal for this is to be able to pull all of these metrics, these measured metrics, which show potential outages in certain areas, and build a map. And this map here, which is on the right, shows potential outages, or maybe not even outages, just poor service at the time. Maybe the tower's overloaded, or they're just shaping your traffic. So our scope for this, which we settled on with our sponsor, was to take the existing project, which was handed to us by a previous team, and work on improving the bugs in it and make it run a little bit better than it currently does. By doing that, right now it's just a box which runs on somebody's desk in an office. So we needed to be able to handle potential influx of users. So we needed to migrate into a new data center to provide new resources to handle this influx of users to support our scaling efforts.
So for our first semester requirements, based on the scope that was provided to us by our professor, our sponsor, we basically decided on a few main portions of work to actually complete and deliver on. So the first step was application, upkeep, maintenance, and continued development. So it was already live on the Google Play Store with active users when we inherited the system, but with updates to the Android API and just further development that we had in mind, we still needed to continue this development. Furthermore, we wanted to actually scale up the number of users. Our sponsor was intending to release this to the entire alumni network to get more users and a wider variety of different locations to get the data from. So we were looking at a potential 100 times increase in our user base, and we needed to make sure that our systems, both on the client side and the server side, were able to handle that influx. And then we also wanted to add some enhancements to the existing application, ranging from actual functionality being added to just some simple usability improvements. But we also needed to ensure that we had continued anonymity of the data, because we are potentially dealing with personally identifiable information, which it would be very bad if we were to be releasing that to the public accidentally. So as for a description of what our actual system looks like, we have a domain model on the screen right now. The main portions of the application as it stood when we inherited it were just a base application user who would generate speed test results regularly through the application, which would then be populated into the speed test map. And those results would all have a whole assortment of information, from the speed that was measured to the carrier, the location that they were at the time that it was recorded, and even what cell tower was being pinged off of to get this information. And that was really the core of what we inherited. There was some extension that we're looking to in the future, where emergency responders will have some specialized functionality, and further down the line, we even want to have a fleet of drones which have cell towers strapped to their backs, which are automatically moved around based on where our application is detecting that there is either outages or strained network usage, so that we can automatically and rapidly provide this response. So obviously, since we inherited the project, we had to deal with some of the existing design decisions. We had to just kind of roll with what they had and just keep polishing with what bugs or whatever it was that we inherited. And we're definitely going to place a focus on understanding our current design better to design features more effectively for next semester. Another thing that we had to deal with was an update to the Android API versions. One of the big things that we rely on is getting regular data pulled from users of the application, but due to changes in how Android deals with applications which are in the background, that's potentially getting taken away from us, so we need to make sure that we keep on track with how we can keep doing that.
So testing, kind of an issue because, again, we inherited this project and there was a lot of code. There was a lot of parts of that code. We didn't think we could test all that because the coverage on it previously was very, very small. And we didn't want to add any tests to that existing code simply because that would take far too much time and the effort just really wasn't worth it, as great as it would be. So our move looking forward is to add tests to both code that we are developing, extra features, enhancements, but also to any bug fixes because if a bug comes up once, it could come up again, and if not tested, we're going to have to deal with it all over again. So currently there's some JUnit tests, which is just Java's sort of unit test framework, that are sitting around, and we're just going to build on that as far as the unit tests. Next semester we mentioned scalability, how we're going to have potentially a lot more users, and we're preparing for that. So we're going to have some load tests and stress tests to prepare our servers, prepare everything for when an influx of users comes in. We want to make sure our systems don't just go down because that looks bad for the app on the Play Store, which could suddenly get poor reviews, and then our whole crowdsourcing dynamic is a little bit ruined. So we need to be reliable with that. And we're working on a more robust test plan. Currently it's just sort of at unit tests. We want to look into more like systems tests, integration tests, and acceptance to cover a wider range of a testing spectrum. To get into our process a little bit, we have a few checks on our process to make sure it's going along well, and we're doing that mainly with metrics. So one of our metrics we're collecting is thousands of lines of code, and the main reason we're collecting that is to go with this next metric, which is cyclomatic complexity. And what we're doing with this is just testing. We have an already sort of complex code base. We want to make sure we're not adding too much complexity because this project, the scope of it, well, it could go on to future projects beyond our team, and we want to keep this as simple as possible so future teams can work on it, and so we ourselves can work on it without having to, just chase things around in the code and deal with a lot of work. As far as process-based metrics, we're tracking staff hours because we have a lot of deliverables that we agreed upon with our sponsor that a lot of them are sort of research-based, or we don't really know how long these tasks will take. So if we start to see these staff hours going higher than we expect, then we know we need to look into this a little more. We need to maybe set firmer constraints on how much time we're devoting to each task. And we are also checking tasks, task in and tasks out, just to see that we're setting stories or tasks that are the appropriate length. If we're not getting as many tasks out as we want, maybe we need to sort of shorten these tasks and assign these tasks a little more broken up into multiple tasks. So for our actual process, we decided to take a modified waterfall approach. So we're dealing with a lot of deliverables, and a lot of them have to be split into multiple tasks. The other situation is, again, I mentioned they're sort of research-based. We don't really know how long these things will take. So we want to split things up and run things in parallel. We don't want to get hung up on, researching, traffic shaping, and just sort of get hung up on that when we have other things we can be doing and we should be doing. And we're doing 3-week sprints. We just found that was a good time length for our team. We benefited a lot from 4-ups, which, it helps communication of progress, issues, risks with our customer, as well as our needs. And that's really our main way to really strictly define our communication with our sponsor, so that he knows that things are moving along or we're struggling with this or that. Risk management. So again, I'm going to keep going back to we inherited this project. and with that came a lot of issues. So we looked into the issues we could and assigned sort of mitigation tasks to address those. And again, the changing in the Android API could potentially basically destroy our project and make it no longer work. So we're looking into that, and that risk will kind of never go away. So we need to continuously track that and keep an eye on it.
So at the end of the day, what we have is a Android application, and compared to the state of it at the start of the semester, we've fixed a lot of critical bugs. There was some crashing that we had to deal with. A number of usability improvements have just been pushed through, fairly minor ones, but making sure the interface behaves as expected. Currently working on a migration from, like was mentioned before, just a box running on somebody's desk to a VM server that is running on some more dedicated hosting equipment, so that it's sort of handled more professionally. We're also looking into the feasibility of how we're currently running this thing in the background. Currently, it just runs cyclically in the background every 11 hours or whatever it is, and sends data off to the server. We're looking to see if that's going to be allowed moving forward on the Google Play Store. There is it's not quite a requirement, but a request to look into adding a feature to measure to passively measure any traffic shaping that's going on, whether watching Netflix, your ISP slows you down more than if you're watching YouTube or Hulu or whatever. That, unfortunately, looks like it is not going to be possible moving forward, simply because Android is increasingly moving towards obfuscating that data from being accessible to external applications for a variety of reasons. And so that, unfortunately, that feature fell through, but that's something we are looking into, and at least now we have done the research so that future groups do not have to repeat it. And we've just made sure that the various communication methods between the application and the server are still running correctly, that they're running in a performant manner. Challenges. There were a fair few. The frequently, not so much changing, but reinterpreted requirements that we lost several weeks of that at the start of the semester. As I mentioned in the previous slide, we're working under a changing system. Android is under active development, so in the present and the future, constraints are fluid a little bit. Going back to there's something of a lack of clear development path and a vision moving forward. Before was mentioned both the drone idea, sending out various control towers. That would be ideally to help first responders in a active disaster area, as you can imagine. Cell service is pretty important when you have to communicate. So currently the application is a civilian application. It's just out on the market. There's some stuff that we're looking into regarding the FirstNet application system. I'm not sure what code would call that. But that's all still in development. There's stability concerns, of course. As I mentioned, very important to be able to communicate in a disaster situation. So have to make sure that it has high uptime, just so that if you are needing to use it, it doesn't just suddenly go down on you. There's some technical debt from previous groups that have worked on it. The code that exists is occasionally not optimal, but we've been working on that as well. As was mentioned, there's been refactoring done, there's been further development. And also the fact that as this is a background application which takes information from your phone and sends it to a server, there's a lot of privacy concerns there. We need to make sure those are tracked and upheld at every single juncture. You know, if people do lose trust in our app, that'd be pretty bad for our whole model. On reflection, several things did go fairly well. I think overall we did handle the very wide variety of work we wound up doing pretty well. We jumped between extremely different tasks, pretty fluidly. There is not a whole lot of documentation here, so we had to familiarize ourselves largely from the source code itself, and from that develop an understanding of what the project actually is. We certainly could have, on the balance, improved our management of our sprints. In fact, a lot of times we weren't so much sprinting as making sure that we were still running in the same direction. We also really should improve our communication between team members. We have a Slack. There's various other tools we could use to supplement that, Trello's, just all those sort of standard tools. And as far as lessons learned that we'll take with us moving forward, cell phones and cell networking, pretty much anything, are pretty difficult to work with. It's also very important to make sure to plan your user stories in advance, or well, more specifically, to plan everything in advance and to collect user stories based on those plans. And also, we need to make sure that we communicate with the sponsor in a prompt and consistent manner. That would have resolved a lot of the issues that we encountered at the start of the semester. In the future, continue maintenance efforts. Those are, it's an active application. Those are always going to be a concern, and we have some particular points that we're looking towards that we've mentioned previously. You can also enhance it with various things like a better UI. The map takes a little while to load currently. It's always good to have a more responsive user interface. We can also make sure to improve our logging and bug report systems. The Android does have a number of libraries and utilities for crash and bug reporting. We should probably implement those. We can also continue our work on scaling the application so that if we do get a surge of users, as was mentioned before, the whole thing doesn't go down. And we also then would design a version of this to integrate with the drone system that was mentioned so that we can actually use it to deploy those drones in a effective and useful manner.
Okay, we just have a little demo to run in the background, but we can start with questions at this point.
Any questions? There really wasn't a whole lot of documentation at all, really. In fact, even just the project statement was the same one they'd given to multiple previous groups, so it was not updated to correspond to the work that had been done. So hopefully for future groups we'll be able to provide an updated statement.
Also, too, on the back end that they had set up, there was a lot of work that they put into that, securing it, because some of the versions of stuff they were using were quite old and had some security issues. So it looks like our previous team put quite a bit of time in separating the boundaries between what's running in user space and the actual host OS. So there was quite a bit of stuff in that regard which kind of wasn't documented. Some scripts that were running here and there, certain people's user accounts that weren't kind of accounted for. So when we were shifting over to running an RIT data center, it was a lot of instead of reconstructing what they have, just picking up what they had on this physical device and moving it to the virtual machine, and then getting that migrated into the data center. So they had a lot of complications.
Yeah, so I'm just wondering, you talked a lot about how much the team had done, trying to figure out what you were doing this semester, basically. I know as some of the other teams, you spend a lot of time just figuring out what you're doing. But what was the actual progress on this project? What was the starting kind of area where you were, and what was the end goal for this semester? And did you meet it?
We're in the process of that. The end goal, for this semester, was to polish up what the other team had in place and make it, really nice and stable to be able to handle this influx of new users from deploying out to the alumni network. So a lot of it was polishing up that, adding some things in for usability, and then making sure it was in an environment which could actually support that.
On top of that, we also had to make sure to push through an update to the Google Play Store, which is compatible with the new Google policies, which changed November 1st of this year, so literally this month. So that kind of consumed a lot of development resources because that was time sensitive.
And one other thing, as we've been talking about the server migration, we are in the very final stages of converting that physical machine into a VM. It's effectively complete pending, just our testing to ensure that the new system is working, but all signs point to yes.
Yeah, like right now we have a debug version of the app which can run against the server of the data center. It's just there's a few issues here and there that need to be worked out.
Real quick, maybe I just completely missed. Your team name is Session Utility.
Yep.
What is your class's name?
Clark, excuse me, Clark Hofgaard? Hofgaard.
He's an employee of RIT. The app itself is called Cellular Metrics. So
So throughout your process, how valuable have you found metrics tracking?
So actually, so we have a few product-based metrics that, since we were working a lot on the research aspect and the actually just getting the environment running from the previous team, which wasn't documented, we didn't make as many code changes as we expected. So as far as our product metrics, lines of code, cyclomatic complexity, they didn't change as much, which is kind of unfortunate looking back. We didn't get much from them. As far as like process-wise, we kind of just monitor them, and it looked like things are going well. It still does, so we're just going to keep an eye on those.
any further questions?
So we are Dashalytics. I'm Joe.
I'm Alex. I'm Nate. I'm Kyle.
And our sponsor is Eric Mansfield. So before we begin, we'll go over what we're going to talk about. So the first thing we'll do is go over the project overview, like the context and scope. Then we'll head into the process methodology and scheduling. Then we'll go into metrics, risk management, design and implementation, testing, and then we'll finish it off with a video demo and what we have in store for next semester. So, overview of the project. So our sponsors, 4D Technology, they are developing an autonomous robot that scans products throughout a store. This data is stored through 4D's private cloud from the robot, and they have an API that we connect to in order to access that data. So our project consists of building a web application that will visually navigate that API. It's essentially a dashboard, so the robot immediately sends alerts that it catches inside the store when scanning the aisles, and then we will display that for the store managers or employees so they know to fix those issues as soon as possible. Here's a picture of the robot. 4D has partnered with DXC to work with us, so they're another one of our sponsors. We have two. So the robot scans the store at approximately 43,000 square feet per hour, which is way more efficient than having, let's say, an employee going through the store and checking every single price tag, every single item, making sure everything is lined up correctly. The robot will take care of that for them at a much more efficient rate. So looking at the scope, the data is separated mainly into 8 categories. The first one is prices. So the robot will scan price tags, and let's say that there's a discrepancy between the price tag on display and at the point of sale system. The store will then know, it'll send an alert to the dashboard. The store will then know to fix those prices immediately because they can actually be in trouble with the state and be fined. Another category that's taken care of is the planogram. So let's say a customer picks up an item, doesn't want it anymore, and then drops it off at another extra area of the store. The robot will detect that, notify the dashboard, and then they can find that item where know where it's located and then know where to put it. Another one is stock. So let's say an item is running low on the shelf. The robot will notify them to refill the shelf as soon as possible. Now, we are more of an iterative approach, and we'll talk about that a little more later. But basically, promotions, products, category, and slippage, we haven't fleshed out all the requirements yet for that, but we have a basic idea of what needs to be done. And then predictive analytics, that's something that we've talked about with 4D and DXC, but we're not sure if we want to go ahead with that. It's been a little rocky with that, but we'll see how that is in the future.
All right, so for process methodologies. So it kind of seemed like a no-brainer to us. The sponsors would give us features every week, and they would want to see those. So feature-driven development, along with an iterative approach, was kind of a no-brainer there. We would basically have to present prototypes every week to them, and they would also have to forward that to stores that would actually be using the dashboards. So we decided on FDD over other agile processes because something like Scrum would be a little too inflexible, would be a little too much overhead as far as all the different requirements with it. We wanted something flexible, and we really just wanted to get the features in front of the sponsors as much as possible. So we also use Trello quite a bit for communications and for planning our tasks. So here's our project implementation board. It has everything from our development to-dos to the bug log and what's in production currently. As far as what's been done scheduling-wise, first 5 to 7 weeks, we really wanted to nail down what the initial requirements are so we have a great foundation for what widgets and what other features we want to build off of. We also made some high-level design decisions, such as how things are going to look aesthetically and how the user is actually going to be interacting with the website. So an important part of this was getting feedback from the wireframes pretty early on for our application. Once we got the green light for that, we were able to go ahead, set up our production environment, development environment. We learned a bunch of different frameworks and tools, which we'll talk about a little later. And then we ended up deploying a demo on Microsoft's Azure for client feedback. For next steps, basically once these are starting, now that these requirements and features that we have implemented so far are a little more solid, a little more clear, we're just going to gather more and build off of that, and I think the sponsor and us will have a better idea of what they're really looking for going further. We also wanted to assign widgets to other specific pages on the website and allow for much more user customization, especially on that main dashboard page where they can kind of put what they want as far as different metric widgets on the that they are prioritized. So for metrics, one of the main ones we focused on were tasks completed per week. This is sort of a generalized version of features per interval. So as you can see here, blue is the actual task completed each week, and red is what is expected. We really had to push maybe 1 or 2 at most tasks to the next week, so we were pretty much right on target there. The reason you see such variations like the 10 at the beginning there is because we didn't really weight the tasks, so if we had 10 small tasks to do that week, then those 10 small tasks were present in this analysis of it. So, other important metrics, we tried to focus more on user experience metrics, so like clicks per action. We want to make sure we keep those down. We want to make sure that The customer doesn't have to go through a million different clicks to get to what they want. Everything should be accessible in like maybe 1 to 2 clicks. In the future, we want to focus more on especially development metrics, especially defects, such as defects per KLOC and the average time it takes for us to fix these defects, because it is such a feature-driven project. The more features we add, the more defects we're going to have in that UI. We also want to focus on some more project metrics, such as release checklists, which are really going to help to make sure we're on task as far as scope and being timely with that, what we actually are going to accomplish. So.
Great, so now we're going to talk a little about risk management. So here is just a snapshot of our risk table we have. Now we don't have time to go to talk about every single one of these, so I'm only going to talk about a couple. One of the first ones is communication problems. So as you guys might have heard earlier, we actually have 2 sponsors effectively. And so just finding times to sit down with both sponsors and just talk about stuff and show them updates, that adds a whole other layer of complexity. The second one is misinterpretation of requirements. So for our project at least, one of the best parts was that we were essentially given a blank slate, and they told us pretty much to run with it and here's some guidelines. But it also introduces a lot of risk, because we could be building the wrong product, not addressing the right metrics, and obviously just not building something that doesn't match their mental model. So now we're talking a little about design and implementation. So here's a screenshot of our dashboard. Now one of the first things we want to focus on in our application is just, again, user customization. This is kind of like the goal. So in the future we'll be able to customize size, color, level of detail, the location of the widgets on the screen, because again, not all store managers care about the same things. Everybody has their own preferences. We also have collapsible sidebars for navigation with a fixed top bar, and then again we opted to create this as a single page application instead of a multi-page application. So as far as frameworks that we use to actually build this, we are using React, because again it's a very well supported framework. We're using Redux for a variety of reasons, because one, it's very predictable. It doesn't matter what component dispatches an action, the same state change occurs every single time. It's easy to debug. If anything goes wrong with the state, we can go straight to the reducers file, take a look at how the state is actually getting modified, and make any changes as necessary. And then component-to-component communication is very simple. All things have to do is just, again, subscribe or just watch the same parts of the store to get any updates. We're using Bitbucket, again, to host our code. Nice thing is that Trello is integrated directly into Bitbucket, so we can use it to track any defects, any new action items, and so forth. And again, as it was mentioned, we are deploying on Azure. So we're also using Plotly, which as our main JavaScript plotting library. And the reason we chose this instead of the 20 other ones that are out there is because they have great support for statistical libraries. We're using Murray as a grid layout library, which again allows us to drag widgets to and from and again to reorder things. And then we're using Redux Thunk for handling asynchronous operations. Now I'm going to quickly go over our testing. So for our application, we're using Jest as our framework. Again, because this was so simple to set up, very little configuration, very easy to test our reducers. And again, because Redux, it actually pairs very well with it, because again, Redux are pure functions, and just inherently pure functions are very easy to test because you don't have to worry about any side effects.
Alright, so now we're going to get into a very brief demo of our early progress. So you're going to see here that we are on the dashboard page. So from here I'm going to demonstrate that each widget has its own customizable features of the graphs themselves. I'm going to show the zooming functionality real quick. I can zoom out, zoom back in. And now we are going to demonstrate the fact that you can drag around the widgets on the screen. Like Nate was talking about earlier, this is accomplished through Murray. So you can drag around, you can put them wherever you want. And now we'll dive into the functionality of being able to add widgets dynamically to the dashboard. So you can click the fab icon on the bottom right. It'll pop up a dialog, and you can just, for now, all you can do is select a new graph to add, but in the future, these widgets will be much more comprehensive. So we'll add a box plot for the purpose of this demo. We'll go ahead and add it. Now you'll see that there's a graph called graph 4. It's a box plot. For now it has some random data populated in it. And now we'll briefly show how to remove a widget in case you don't want it anymore. You just click the drop down arrow at the top by the title and select remove widget. So now you'll see we have 1, 3, and 4, 2 is gone. Now we'll show quickly the navigation, how it works. So at the beginning you saw we had the text and the icon, but if you click the hamburger menu, it'll collapse in and you'll just have the icons, and when you hover over, you'll get the supporting text. So that'll about end the demo. So to quickly go over what we have done well and what issues we came into, how we solved them this semester, and what we plan on doing next semester. So for some issues and blocks, we had a pretty significant learning curve for some of the libraries we chose to bring in. That's also because we have a decent variation of skill level between the team members in certain areas. We had an NDA kind of problem, a little bit of a hiccup with getting it authorized and sent back and forth between the sponsors. We had some files that were being mysteriously skipped in our initial deployment of this to Azure, and we had a rough time trying to understand the API and exactly what some of it means. So how we went about solving some of this. So for the learning curve, we decided to start hopefully to try to onboard people very early into what React is, what Redux is. And we even had things that we called like team tutorials, where we'd sit down and if someone just committed something or pushed something that they thought was pretty complex, they'd sit down and we would talk about it all together and walk people through so everyone's on the same page. For the NDA clearance, we basically acted like we had an NDA anyway, even though it wasn't officially back and forth. For the files, that we took a look, originally we took a look at a Webpack and tried to adjust configuration files, but that wasn't working out, and so we ended up essentially tossing the initial, we had a code template we kind of started with, kind of tossed it, and just did a React CLI project instead. It made it more smooth. And for the API, we really tried to communicate very early and often with our two sponsors, with 4D and DXC, to really understand the JSON responses and what some of that jargon in it and what some of the acronyms meant. So for next steps, we plan on diving deep into the feature pages that you saw on the nav, so like prices, stock, compliance, things talked about earlier. Once we do that and we populate all that with real data, we can begin to make the dashboard much more relevant. You'll be able to pull in data from those pages that you want to see immediately when you load in. We plan on refining some metrics that we currently have and definitely adding new metrics, especially development ones. We also want to look into database access. That would go along with our user preference dashboard that we want, like if they want a different color, different size, different locations, what they want, you save it all in the database. And we also want to begin discussing in more depth with the sponsors what exactly they want from predictive analytics. So yeah, we want to flesh that out some more. Thank you. Does anyone have any questions?
Yeah, so your requirement slide and everything that you talked about, like what was expected out of it, from my understanding, are you guys not making the actual functionality of that little robot, buddy? You're just making how to display that.
Yeah, the robot was already built by 4D, so that will scan and then upload it to a cloud, and then the cloud is basically an API extrapolates it from the cloud, and we're reading in and trying to display it all for the store managers of the various stores.
Okay, that makes a lot more sense. I was really confused when you had said that, and then the demo, you were just like, here's the dashboard. And I was like, what?
Sorry for that.
No, that's fine. That makes a lot more sense. Thank you.
Could you tell me a little bit more about your process with how you planned and scheduled and estimated what your tasks were going to be?
So for the planning, we basically had a Trello board, kind of labeling out. I know if we go back to that graph where we had that graph showing like estimated versus actual. This is essentially just taking our Trello cards, and we had like checklist items on the Trello cards. So that's what this is. This is each thing is a checklist item. That's kind of how we did it in the beginning. Because again, a lot of the requirements aren't initially they aren't all just given to us up front. It's kind of, we have a lot of free roam with it. So we kind of, that's why the iterative thing came in because we wanted to show them what we had, and they would keep going on with us with the requirements of what they want.
Was that a detriment at all, or did you find that to be really useful?
You mean in the sense that we didn't have initial, like, all the requirements?
Yeah.
I mean, it's kind of both, because, I mean, you don't, I mean, it's nice to have all that freedom, but also it's nice to have a lot of direction. So, I mean, it depends. For us, we ended up working with it with the iterative approach, so I don't think it was too bad for us.
Can you tell us a little bit about how you're confirming that what you're delivering is satisfactory? Do you have any formal second steps and anything like that?
Yeah, so we always have a meeting every week with the sponsor. Also, if we deploy it on Azure or just show them screenshots and stuff, they'll tell us what they think, and depending on that feedback, we'll go back and make changes. This is really what we've been doing.
Other questions for them? All right, please. Let's thank the team.
All right, so as you were just told, we are Team Celestial Orca, and today we'll be presenting our project Info Kiosk, which was given to us by our sponsor, BizCloud Experts. So BizCloud Experts is basically an AWS solution provider, and what that means is that they provide consulting solutions to external companies for if they want information on their AWS architecture. So they provide architecture and advisory information related to cloud services. They also provide operations management to any company that wants assistance with managing their cloud operations. And they also provide IoT solutions in case any company wants to delve into that space. Our main point of contact is the CEO, Nagesh, and he also delegated a small team of developers in case we need any additional information or domain expertise. So for our agenda, we'll be giving an overview of what Info Kiosk is, followed by the requirements in architecture, the process methodologies, the plan, metrics, risks, design choices, lessons learned, and future plans, and then we'll be open for any questions. So what is Info Kiosk? Info Kiosk is a smart TV-driven electronic bulletin system, and the key objective is to allow anybody in an organization to display information to their fellow associates. This product targets any and all types of enterprises, and anybody who wants to display information to people in their company on any type of bulletin board style display can use our system. And it also allows for the content that is displayed on the TVs to be securely managed. So what does the system exactly do? So it allows you to register any smart TV throughout your organization, and then once you register the smart TV, you can push content to that TV for people walking by to view. So this is an example of what a smart TV would show. Content is displayed on these tiles, and then on the tiles you can display information such as if you've lost something, any event notices, or any emergency information you need to show. End users who view the content can also scan QR codes if they want to go to external pages. And then you can also request for content to be pushed to the TV if you want.
So I'll be talking about the requirements and architecture. In the previous slides, Dan had talked about a little bit of the components involved in our architecture. So if you guys don't remember what they were, I'll break them down for you. So it is separated into 3 sections: the web application, the infrastructure, and the smart TV application. So in each of these sections, they have their own architecture. I'll start with the smart TV application. It's an Android application that's run on a Android TV, and it's built on Android SDK. The infrastructure utilizes Amazon Cloud Services, and the web application, is built with Angular 5 web framework. So as you can see, this is our high-level domain model. The web application and smart TV communicates with each other through Amazon Cloud Services, and those are the services available. So for the requirements, we wanted to grab the key requirements that kind of describes the key behavior of our system and highlight them. So the smart TV will have a functionality that submits a TV registration request. And the smart TV will also display the content in the form of a card in a tile-like layout. So each of these cards contains a title and a description, and also a QR code. The web application will handle the registration of the smart TV device and also create and push content to the smart TV device. So here are some of the requirements that we concluded would be in scope and out of scope. We came about this decision through factors involving discussions with our sponsor for what needed to be in the MVB, and as well as what we thought we identified in one of our risks, learning like unfamiliar tools.
So for our process methodology, the process we chose was Kanban. Originally, we started on Trello. As you can see here is our Trello board. Then our sponsor created 3 separate repositories for us for managing our code. So to manage our development tasks, we thought it would be better to move to GitHub projects, just because those were a lot of things to keep track of. Over time, managing 3 different GitHub project boards became very cumbersome, so we ended up moving back to Trello over time. So to develop, using our process to develop or to create features and tasks, we met up and we would sit down and just come up with a list of features that we needed for the MVP. We broke those features down into separate tasks and planned those into separate sprints. And then we made estimates for those tasks in those sprints. And then we continued to develop. Also, for interacting with our client, we would meet every Thursday. One of the issues that we saw come up was conflicts with schedules. So if we needed to reschedule a meeting, we would reschedule to Friday. Oftentimes, we also noticed that we needed to ramp up and work in more meetings and work in more feedback. So we would start, to get that done, we would start meeting on Tuesdays and just get some feedback on different documents that we sent in. And we would send documents through via email and then send a second email follow-up to request them to be reviewed. It'd be right before our meetings. And we also consulted with the team via Slack to get some clarity on the different AWS architecture issues.
All right, so once we went through all of our process methodologies and getting all of our, kind of planning and all that down, we started to develop our schedule. So initially, we just kind of started working off of our 4-up charts and using benchmarks that were given on the SE course website. From this, we knew what had to get done each week, kind of almost like mini, week-long sprints, because we had what needed to be done, what was done, and kind of ran through it like that. We just didn't really have a ton of strict deadlines and didn't have any longer-term goals laid out, on paper. So, this kind of was a problem because we had stuff that we were getting done. We just kind of didn't have a specific direction. So to accomplish that, we set up a Google Sheet style schedule to track which items would be due and when, and then populated that with tasks that were given from the SE course website, as well as tests that we created based on requirements and features and tasks that were created as we went along through the project. And then we put those into the spreadsheet, and then it mapped out pretty much how long we had to work on them. So, we had this down, but then we still kind of didn't have any set grouping of tasks. So we eventually came up with sprint plans, and those gave us more clear-cut definitions on the due dates for those specific tasks. So this is kind of a general plan of what occurred over the semester. We started with our planning phase, where we gathered our project plan up. We did our synopsis on what our product was going to be, and then we kind of started to put together a domain model. So then we moved on to our design phase midway through September, and this gave us more time to work on our requirements documentation, and then from that, our use cases, sequence diagrams, and even more modeling to flesh out the design. This was the longest phase that we had, and where we experienced probably the most amount of development so far. But then at this point is kind of where we started to switch over to the 2-week sprints. So for our first sprint, we delivered, we got done things such as doing research on the smart TV to figure out which OS would be the best to use, built up kind of a web app skeleton of what we wanted that to look like. We got our AWS tools, what we needed figured out, as well as some mock-ups on the UI design and what we wanted the product to look like, and kind of what to show our sponsor to get kind of validation on where we were going with the project. Then our second sprint came up and ended in the middle of November. And at this point, we wanted to declare our API endpoint functionality. So we had a direction to go for our endpoint on AWS. We updated our use cases because we found out that there was some functionality that we might not quite be hitting. So we wanted to make sure that we had that written clearly, what we are going to be actually accomplishing with our framework. We got our database schema set up and then revisited old documentation to make sure it was updated and clear-cut what we had to deliver, so that for Sprint 3, we could write out Lambdas, connect the APIs together, attempt to set up our Internet of Things and connect to the smart TVs. Where we got to, currently, task-wise, we are mid-Sprint 3, so not quite where we wanted to be. Our ultimate goal for kind of the MVP for this semester was going to be to push one content tile to a smart TV device. Pretty much all the framework is built, and we've also got a smart TV component and a web app component. However, they aren't connected yet, unfortunately. We're very close, though. And our sprint ends today, our third sprint, and obviously, unlikely all of our goals will be achieved currently. So next we've got our metrics and measurements, which we decided to record throughout this project. So here we can see we tracked effort and time, obviously, which is pretty much the amount of time spent overall on all of our tasks throughout the project. And then we also got our lead time, which pretty much was how long it took us to complete a subtask of a feature or deliverable from when we started working on it to when we sat down and finished it. And then using that information, we could figure out how much time we allocated to certain tasks in previous sprints or release windows, and then plan further releases based on that, that sprint. So once we kind of got our metrics down, we built, obviously, our time tracking system. There was a template that was given, I believe, from Dr. Valino for the SE course as a whole to everybody. It was a template. It didn't seem to quite work on Google Docs, so we kind of rebuilt it from the ground up, and this is sort of what it looks like here. So it's pretty similar. We've got estimated time, accounted time, and then on the bottom here is a list of different requirements or tasks that we implemented, and then what their type was, how long it took them, whether or not they were accomplished, and then you could sort that and get statistics based on that, which obviously the display of the statistics hasn't been implemented yet, but definitely something you can gather.
So I will discuss some of the risks that we encountered. So we have a living risk exposure table, and we also handle risks real time with our 4-ups. But I just wanted to talk about a few key risks that we ran into that we also had some that we ran into. So first was our lack of AWS knowledge as a team. That was one thing that we were really concerned about. Only one person on the team had prior knowledge of a lot of the tools that we were going to have to use. So to handle that, we kind of just sat down and took time and explored AWS console, different tools. One of the things that stemmed from that was that our sponsor wanted to develop a kind of best practice framework for their developers, and they wanted to introduce infrastructure as code through CloudFormation scripts. Due to that, our user roles lost a lot of permissions from the console, so we couldn't create a lot of things on our own, and we had to wait for the CloudFormation scripts to be tested and validated. So a lot of that was, just we had to try to create things on our own using the scripts, and then report back to our sponsor whether we were able to create those things or not. Lack of smart TV development experience throughout the entire team, that was a huge risk for us. So one of the things we did to mitigate that was just doing, like we just said before, we created a large document comparing a lot of operating systems that could be used to create a smart TV application. And we also designated a couple of developers to kind of just do some research and development, run through some tutorials to kind of circumvent that ahead of time before we actually got to that development. Lastly, we spent a lot of time on the design phase, as stated before. One of the things that led to that was just our conflicts and schedules. So, conflict schedules and discussing things with the sponsor digitally through email kind of led to us not being able to get feedback when we wanted. And one thing we did to mitigate that was just to kind of set deadlines on when we needed feedback and when we would get things to the sponsor.
All right. So for our project, we had to make a few design choices and follow a few constraints. So the major critical choices that we had to deal with were the Smart TV platform, the web app framework, the database technology, security concerns, and the cloud infrastructure. So for the Smart TV platform, we considered a lot of different TV OSs, like Apple TV and Roku, and ultimately we decided on Android TV because it had a familiar UI to us. It was multi-platform, as in a lot of brands use Android TV. They have like Sony, Sharp, Philips, and also a lot of us had experience of working with Java, so we figured that would have the least amount of risk for us to use. For the web framework, we decided on Angular 5, mainly as because of the project sponsor. We did consider using React and Vue. However, BizCloud strongly suggested that we use Angular 5, and some of the members on our team had experience working with that, so we figured that would be the path of least resistance. For the database selection, we considered a non-relational database, DynamoDB, because somebody had experience with that. However, because of the customer's suggestion, we decided on MySQL, and we have a MySQL database running on AWS RDS. For security, we had three major sections. The main decision we made is that we should limit Smart TV registration by the client ID. This is so that not anybody can just register a Smart TV to the system. For example, without limiting it by the client, somebody from U of R could essentially register one of our Smart TVs to their system and push content. For user authentication and database security, we use AWS Cognito and Bastion Host. Cognito is basically a built-in service which allows for user sign-up and registration. Bastion Host acts as a layer between the public and our actual SQL database. So for the client-approved architecture, we have AWS Lambda for our web app backend and intercloud communications. We have AWS S3 for static website hosting. We have AWS IoT for MQTT protocol communications to the Smart TV. RDS for storing our SQL database. Android TV, as said before, and Angular 5 for our web framework. This is just a little diagram of the infrastructure. Basically, the web app is here. It's all stored in S3. The backend calls are sent to Lambda, which interacts with IoT for sending content to the TV, and also writing stuff to the database, and then user authentications through Cognito.
So for the lessons learned and future plans. So we weren't really able to follow our process very strictly, and that caused many issues early on. We were defending the process, but as the weeks ran on, we fell off, and there was a lack of organization. So we needed to also improve our integration project management. Each of us had developed the architecture for each section of the sections, and we weren't able to put them all together, and that was mainly a big issue coming close to the end of the semester. We also had organization and communication as a group outside of the group meetings. Although we did a lot of talking through the group meetings and communication through there, when we were outside of that, we weren't able to get a lot of communication through the Slack. We also had a very hectic schedules without any overlap, so many of our members could not meet on days when some could. So here are some of the things that we plan to address. We decided to change the process to a Scrum ban and delegating one person to manage the process. Another thing that we wanted to change was have stand-ups, some more frequent progress updates to create awareness of the work done in each component of the architecture. Also, we wanted to have code reviews and feedback blocks, which is designated blocks of time to hold each member accountable for the things they create and show transparency throughout. Also, we wanted to develop a test plan and include it into the process and schedule. So, any questions?
You guys talked a lot about using AWS for most of what you did. Do you think that working with AWS so intensely, you guys have now a clear understanding of what you have to do in order to keep using AWS moving forward?
So we did spend a lot of time developing that groundwork and building like the team's knowledge of AWS. That was one of the main requirements from our sponsors, that the entire system had to be built on AWS. So I think going forward, we did lay a lot of the groundwork out. Like the infrastructure diagram that I showed you before was approved by the client, and we feel like we can at least build from that if we need to add any more features, but for now, that's enough for making like a minimal viable product and going forward for the future. I thought I saw a hand over here.
Oh, yeah, they wanted it to be serverless too, so like.
Yeah.
You said your sponsor provided you guys with a dev team. How have you utilized them and sort of what your plans are around that?
So, the main reason we did get provided a dev team, so like I said, our main point of contact was Nagesh originally, but since he's the CEO of the company, a lot of times he would be extremely busy. So then when he noticed that we needed a lot of feedback on our documents and that was kind of halting our work, he gave us like a dev team of like an infrastructure engineer. So personally, like on Slack, I would communicate directly with him to like if we had any problems with the AWS account for like rights and permissions. And then we also had like people who had experience with IoT, and so mainly we use like the dev team because it's very hard to get direct communication with Nagesh all the time.
You pointed out that you'd like to have a test plan, and I'm just wondering what aspects of testing have you taken on or will you challenge me to take?
Right, so we more so acceptance testing right now. One of the biggest issues for us was just the domain and just trying to connect all three of these large components together. So right now it was just acceptance testing, getting different requirements understood for the entire project, especially in the AWS side. So yeah, as we started writing code, we started realizing that we need more unit testing and things like that in the future, especially when we're going to integrate these parts. So we don't want to do a lot of regressions. So that's one of the things we're kind of looking forward to.
And then one of the biggest things is we actually did some UI mockups to kind of get it better, because we were especially confused towards the beginning of the semester about what exactly they were looking for. So we figured it'd be best to do a quick mockup just to kind of understand and try to validate what they were looking for. And that actually really got us moving forward in terms of what understanding what the sponsor was looking for. So when we kind of use that to build our requirements, we can continue to kind of use that model and put out a product that will meet those requirements and use that in our test plan.
Any other questions for the team? Okay, let's thank the team.